Hi there, what it feels like in this era. We are all instant through technology, innovation, invention, and information. Everything is easy and efficient.
What it feels like to live in this era. Through transformative form of technologies, we can explore science, culture, and other informations that can influence our society.
What it feels like to live in this era. We are all accessible in the internet. There are scam, unreliable sources, and other related cyber attacks. That's why we need to be aware and to be computer literate.
We are living in this IT era.
I met Mone Pumayani.
Angel Kisolito,
And Irish Claire Santos, your reporters. Today, we are going to talk about computer system organization and architecture. So join us as we discuss this and this.
Computer organization and computer architecture. Ano nga ba ang pagkakaiba nito? Computer organization is a study of the system from a software point of view and gives overall description of the system and working principle without going into much detail. In other words, it is mainly about the programmers or user point of view. Samantalang ang computer architecture naman is study of hardware point of view and emphasize on how the system is implemented. Basically, throws light on the designer's point of view.
Computer organization. Focus on computer organization. The how of a computer system. It deals with the implementation and physical arrangement of the components of a computer system to realize their architectural specification. Scope concerned with the hardware details, control signals, interfaces, and memory devices. It describes how the components of the system are interconnected and how they operate to achieve the functionality defined by the architecture. Sa level po naman tayo, low-level design issue. Example, the specific implementation of a cache memory system, including its size, organization, and replacement policies. Dito naman tayo sa computer architecture. Focus the what of a computer system. It deals with the design and structure of a computer system by seen by a programmer. Scope encompasses the attributes of a system that are visible to the program, such as instruction set, data types, addressing, codes, memory organization, and input or output mechanism. Level, high-level design issue. Example, instruction set architecture or ISA of a processor which defines the set of instructions that processor can execute.
Para po lubos nating maunawaan ang pagkakaiba ng computer organization at computer architecture, ang computer organization ay tinutukoy ang interaction within the computer. Ito po yung physical design ng ating computer. Saka sinasagot po nito ang mga tanong na how many registry, what registry, and how many registry does the CPU have. Samantalang, ang computer organization naman po ay nagpa-pertain sa structure and behavior ng ating computer. Ito po yung logical design ng ating computer. Tinutukoy naman po nito ang instruction set, ang representation of data gaya ng mga integers, characters, and pati po mga floating point types. Saka nandito rin po yung mga key, output, and input mechanism natin. And syempre, nandito din po yung memory techniques. Let's think of this. Ang computer architecture ay tulad ng blueprint ng isang bahay. Tumutukoy ito sa bilang ng silid, layout, at ang overall outcome ng structure. Samantalang ang computer organization naman ay ang aktual na pagtatayo ng bahay. Kasama na dito ang mga materyales at kasangkapan at pagsasaayos pa ng mga ibang gagamitin sa silid. Sa madaling salita, ang computer architecture tumutukoy sa kung ano ang ginagawa ng isang computer system. Samantalang ang computer architecture naman ay ang paglalarawan kung paano isinasagawa ang function ito. Parehong mahalaga ang mga ito sa pag-unawa at pagdidisenyo ng effective at efficient na computer system. Ito naman ang mga attributes ng computer organization. First is the control signal. It is a pulse or frequency of electricity or light that represents a control command as it transfer over network, a computer channel, or wireless. Pag-usapan naman natin ang computer or peripheral interface. Peripheral is a device connected to a host computer but not part of it, just like this and this. Samantalang ang interface naman is a point of interaction where software or computer hardware or peripherals such as computer monitor or keyboard, mouse, and even touchscreen interfaces. Meron tayong two types of interfaces. First is the hardware interface. It exists in the computing system between many of the components such as the various buses, storage devices, and other I or O devices. Meron tayong software interfaces na nag-refer naman sa range of different types of interface or levels. Next, meron din tayong memory. Memory is, as we all know, memory is the collection of storage unit and other devices together.
Structure and function. Complex system. How can we describe or design it? Hierarchic system. A set of interrelated subsystems, each subsystem hierarchic in structure until some lowest level of elementary subsystems is reached. At each level of system, the designers is concerned with structure and function. Structure is the way in which components related to each other. Function naman is the operation of individual components as part of the structure. Basic computer functions. Data processing. Data processing refers to the process of collecting and manipulating raw data to yield useful information. Data storage is a general term for archiving data in electromagnetic or other forms for use by computer or device. Data movement. Computer must be able to communicate with outside world. Data must be accessible to devices outside computer. Two types of data: peripheral data and data communications. Control. Some things need to monitor operating and maintain control of data processing, data storage, and data movement. Automated control of computers' resources.
Functional view of von Neumann model. The von Neumann model consists of 5 major components: the input-output unit, arithmetic logic unit, memory unit, and control unit. First is input unit, getting information into the computer. Example is keyboard and mouse. Is arithmetic logic unit, a unit in a computer which carries our arithmetic and logical operation. Fourth is the memory, storage of information, data or program. 5. Control unit, make sure that all the other parts perform their task correctly and at the correct time. The system bus model. A refinement, the von Neumann model. The system bus model has a CPU, ALU, and control, memory, and an input-output unit. Communication among components is handled by a shared pathway called the system bus, which is made up of the data bus, the address bus, and the control bus. There is also the power of bus, and some architecture may also have separate I/O bus. Data bus is a system within computer or device consisting of connector or set of wires that provides transportation for data. Address bus is a computer bus architecture used to transfer data when devices that are identified by hardware address of the physical memory, the physical address which is stored in the form of binary numbers to enable the data bus to access memory storage. Next is control bus. This computer bus that use the CPU communicate with devices that are contained within the computer. This occurs through physical connections such as cables or printed circuits. Next is peripheral bus, also known as input or output bus or I/O bus. It is the data pathway that connects peripheral device to the CPU. The PCI and USB buses are commonly used in PCs, ISA, ASA, and BL bus. Microchannel buses were used in earlier PCs.
The motherboard. Motherboard, a printed circuit board containing the principal component of a computer or other devices, with connectors into which other circuit boards can be slotted. North bridge is the controller that interconnects the CPU to memory via the front side bus or FSB. It also connects peripheral via high-speed channels such as AGP and PCI Express. South bridge is one of the two chips in the core logic chipset on the personal computer or PC motherboard, the other being the North bridge. The South bridge typically implement the slower capabilities of the motherboard in a North bridge or South bridge chipset computer architecture. System bus is a pathway composed of cables and connectors used to carry data between computer microprocessor and main memory, related to Omnibus, communication system between components. The system bus connects the CPU with the main memory and, in some system, with the level 2 or L3 cache. Other buses such as I/O buses branch off from the system bus to provide a communication channel between the CPU and the other peripherals. The system bus combines the functions of three main buses, which are as control bus, address bus, and data bus. Control bus carries the control, timing, and coordination signal to manage the various functions across the system. Determines the data process. Address bus is used to specify memory location for a data being transferred or determine where data should be sent. Data bus, which is the bidirectional path, carries the actual data between the processors, the memory, and the peripherals. Carries the data that needs processing. This is the motherboard diagram.
Let's talk about digital components. First, we have the transistors. Transistors is a semiconductor device used to amplify or to switch electronic signals and power. It is one of the building blocks of modern electronics. And here's why. Transistors can be easily replaced through vacuum tubes. They are smaller and cheaper. They are made in solid-state design. They are made from silicon or sand, which can lessen the heat dissipation. It was invented by William Shockley and his company in 1947 at Bell Labs. Next is the microelectronics. Microelectronics are literally small. It is a computer made up of gates, computer cells, and interconnections. This can be manufactured as a semiconductor like in silicon wafer. Next is the level of integration. Level of integration is the number of gates in an integrated circuit. So let's take a look at this figure. Small-scale integration or SSI is ranging from 10 to 100 gates, while medium-scale integration or MSI is ranging from 100 to 1000 gates. Large-scale integration or LSI is ranging from 1000 to 10,000 logic gates. while on very large scale integration or VLSI on 10,000 to upward gates. These levels are approximate, but the distinctions are useful in comparing the relative complexity of circuits. So these are the scientific prefixes. For computer memory, 1 kilo is equal to 2 raised to 10 or equal to 1024. For everything else, like clock speed, 1 kilo is equal to 1000, and likewise for 1 mega, 1 giga, and etc.
Data representation. A common form of data are letters of the alphabet A to Z, numerals 0 to 9, some symbols at and an asterisk, and certain control characters C, T, R, L, and shift. This type of data is convenient for human being, but all of the data in digital computer are represented in binary form. Some coding systems are used to represent this data into binary form. The famous coding system being used for data representation are ASCII or American Standard Code for Information Interchange. ASCII is used in almost all present-day personal computer. Each alphabetic, numeral, or special character is represented with a 7-bit binary number. 28 possible characters can be represented. The 8-bit may be set to 0 or used as a parity bit for error checking on communication lines or other devices specific function. Example: char A is equal to 65 in decimal, 41 in hex, 01000001 in binary. EBCDIC or Extended Binary Coded Decimal Interchange Code. EBCDIC, pronounced either hepsudic or hebcodic, is a binary code for alphabetic and numeric characters that IBM developed for its larger operating system. Each alphabetic or numeric character is represented with an 8-byte binary number or string 8 zeros or first. 126 possible characters, letters of the alphabet, numerals, and a special character are defined. EBCDIC uses more or less the same character as ASCII but different code points. BCD or Binary Coded Decimal. In BCD, a bit binary number were used to represent one decimal number. Highest decimal number were coded to BCD is 9 or 1001, thus 1010, 1011, or 1110 and 111 were not used. To encode the number such as 43 use or 43D is equal to 01000011B. The BCD format usually used in the BIOS at personal computer or PC to keep the date and time for historical reasons.
Number system. Fundamental to understand how computers work is understanding the number system that computers use to store data and communicate with each other. Number system being used to understand computer. Types of number system: decimal system, binary system, octal system, and hexadecimal system. Number 1 is decimal system. This system is commonly used by human beings for counting. The symbol used are called Arabic number, consisting of 10 symbols. The symbol is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. The base of the decimal system is 10. Next is binary system. This system is used in digital computers. They operate in either 1 or 2 state, either on or off, positive or negative. It uses only two symbols, 0 and 1. The base of binary system is 2. The binary notation 0 and 1 are called bits, which is acronym for binary digits. Next is octal system. This system is shorthand method for replacing groups of binary digits by single octal digits to reduce the number of digits required in representing any number has a base radix 8 consisting of 0, 1, 2, 3, 4, 5, 6, and 7. The base of an octal system is 8. And last is hexadecimal system. This system is simply a method of expressing value represented by binary numerals. It is the combination of numbers and 6 alphabets, namely 0, 1, 2, 3, 4, 5, 6, 7, and 8. And the alphabets is A, B, C, D, E, and F. These 6 alphabets represent digits 10 through 15, and these are treated as ordinary numeral. The base of the hexadecimal system is 16.
Conversion from one number system to another. In mathematics, a number can be converted to a different number system. For example, Hindu-Arabic can be converted to Roman numerals and vice versa. Similarly, all 4 number systems in computers are equally capable of representing any number. Furthermore, a number can be perfectly converted in the various number system without any loss of numerative value. The following table compares decimal, binary, octal, and hexadecimal numbers. Number system conversion. To convert decimal to any system, repeat division by the new number system base techniques is used. The steps are as follows. First, divide the decimal number to be converted to the new base. Example, if it is binary, then divide it by 2. If it is for octal, then divide it by 8. And if it is for hexadecimal, then divide it by 16. Write the remainders on the right side. Repeat the process until the quotient is 0. Collect all the numbers starting from the last quotient going upward. And then you get them. Let's try. Try natin sa decimal to octal. Same example, 74 base 10. Ang base naman natin dito, or ang quotient naman natin dito ay 8. So 74 divided 8 is 9. 9 times 8 is equal to 72. So 74 minus 2 is 2. Kaya yun ang reminder. Then, 9 divide 8. Go 1, 1, 2. Then, yung base na 8 ng octal ilagay doon. And yan ang decimal to octal. The steps on converting binary, octal, and hexadecimal to decimal follows the position notation. First, starting from the right side, the base, example is 2 for binary, 8 for octal, 16 for hexadecimal, will raise b power to 0. The next number to the first power, the third number is to the second power, and go. Get the sum of all, and answer represents the decimal number. Get the sum of all the numbers, and the answer represents the decimal number. Let's try this. Let 74 base 10 be our example.